Okay, just 2 more examples and you guys can work on your delta math for homework. All right, again, we want to get x squared and x isolated, which these are actually on the wrong side, so I'm going to go ahead and rewrite this. So I'm going to say 3x squared. Moving this 2x over changes its sign, so minus 2x. Moving that 3 over changes its sign as well. Okay, then I have to have x squared and x. So I can't have this 3 here, so I'm going to go ahead and divide every single term by 3. I'm going to get, x squared, negative 2/3 x. And because I now have x squared and x isolated, I can go ahead and just add some space. And then 3 divided by 3 is 1 plus same space. All right, going ahead and cutting negative 2/3 in half. People have trouble with this, but you can just take negative 2/3 and multiply by 1/2. You can either cancel out the 2's or just get a negative 2 over 6, which is a negative 1/3 there. So I'm going to add negative 1/3 squared to both sides. So negative 1/3 squared to both sides. All right, so then when I go ahead and factor the left side, it's always just going to be whatever's here and exactly whatever's here. So minus 1/3. And then square that quantity. Okay, and then over here, you're going to get 1, and this will end up being a positive 1/9, so 1 plus 1/9. Well, if I want this to have the same denominator, I would multiply top and bottom by 9s, so I would have 9 over 9, because that's still a 1, and then 9 over 9 plus 1 over 9 is 10 over 9. So without a calculator, you can do all these fractions. All right, and then I'm going to go ahead and I now have this square root method, so I'm going to go ahead and square root both sides. Whoops, that was a little messy, but well. Left side is absolute x minus 1/3. Right side is square root of 10 is nothing, 2 and 5 can't reduce. Square root of 9 is a perfect square, it is a 3. And because I have that radical, I can go ahead and do my positive negative route, just all within that one problem. So how do I solve and get rid of this negative 1/3? Well, I would add 1/3 the other side. So I would get x equals positive 1/3 plus or minus square root of 10 over 3. And because, again, I have these 2 3's on the bottom, same denominator, I can go ahead and just write this as 1 big 3 on the bottom and literally just copy boom, boom, boom on top. 1 plus minus root 10. If you were taking an EOC, you would absolutely never see the answer like this. You would definitely see the answer like that. All right, and last problem. Because I already committed to a second video, I might as well do a second problem. Also, you guys have missed out on several parts of the honors-y stuff, so I do want to go ahead and do one of the more challenging problems. So here's a triangle, a right triangle specifically, and the directions say find the unknown lengths. So I want to find these 2 sides here. So if I'm given just a right triangle and I have no information besides the sides, I'm going to go ahead and do Pythagorean theorem. I'm going to do a squared plus b squared equals c squared. Okay? Keep in mind that c is always across from the 90, so I know that c squared is going to be 2 root 17 squared. Everything else is just pick a side. So I'll go ahead and do x minus 6 squared as b, and then x squared as a. Okay, so I don't need the picture anymore, so I'm just going to go ahead and scroll up here. All right, so then I'm just going to go ahead and clean this up. Well, obviously x squared is just x squared. X minus 6 squared is square the first, square the last, and double the product of the middle. So multiply it out on your own. I just did the shortcut. Okay, and then over here, 2 root 17 squared is the same thing as multiplying 2 root 17 by itself. Well, keep in mind that outside, 2 times 2 is 4. And then root 17 times root 17 is some big number, but it's going to be a perfect square, which is 17. So there's that guy. Okay, then cleaning up this left side, x squared and x squared give us 2x squared minus 12x plus 36 equals 68. Okay, and we're assuming, I'm sorry, this is also minus 12x. We're assuming we're completing the square here, because you could probably solve this some other way if you wanted to, but we're going to go with the new method we just learned. So I do want to go ahead and move this 36 over. So I'm going to get 2x squared minus 12x equals, and then that's going to be a 32. I have to have x squared. I cannot have anything else. So I'm going to go ahead and divide each term by 2. So I'm going to get x squared minus 6x. And because I have now isolated x squared and x, I can go ahead and add some space. And half of 32 is 16. And again, add some space. All right, same process. Hopefully by now you've got it, but take that b term, cut it in half. So half of negative 6 is negative 3. Square it. Half of negative 6 is negative 3. Same thing on both sides. All right, just shortcut this guy. So just take the first and take the last. And then square both sides. Okay, 16, and this will end up being plus a 9. 16 plus 9 is 25. And now I have square root method. So square root, you get absolute x minus 3 equals 5. And because I do not have that radical, I do have to do my positive and my negative route separately. So I'm going to say x minus 3 equals positive 5 and x minus 3 equals negative 5. And then solve both of them. Same math though. Add 3, you get x equals 8. Add 3, you get x equals negative 2. All right, so then this is a real world problem, kind of. So if x equals 8 or negative 2, well, I couldn't plug in a negative 2 in for that side length there. So I would have to get rid of this answer. My answer is 8. But the question said, find the dimensions. So plugging in an 8 here, I just get 8 whatever units. And then 8 minus 6 is 2 whatever units. So I'm just going to put a U for units. Okay, and that is your final answer. And that guy is sort of an honesty problem. All right, I know this was kind of a longer video today. I apologize. But go ahead, just do 6 of those Delta Math problems, and then you are done.